Myself, Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I wish to tell about the question bank questions on quantum mechanics. So, the problem is calculate the velocity and kinetic energy of an electron having wavelength of 0.21 nanometers. So, the given data is wavelength. So, wavelength of lambda is equals to 0.21 nanometers. So, we have to calculate the kinetic energy of an electron. So, Ke is equals to how much? And calculate the velocity of the electron. So, V is equals to, we need to calculate. So, the formula which we are going to use is lambda is equals to h by root 2n a. So, we know that lambda, h is the Planck's constant, m is the mass of the electron, e is the energy. So, that from this, we have to calculate the energy. So, that is E. So, E is equals to h square by 2m lambda square. So, that is equals to substituting the value. So, where h is equals to 6.625 or 626 into 10 power minus 34 joule second. So, substituting 6.625 into 10 power minus 34 square divided by 2 into mass of the electron is 9.1 into 10 power minus 31 into the wavelength which is given 0.21 nanometers. So, when converted into meters, 0.21 into 10 power minus 9 meters. So, square. So, calculating this, we'll get 5.468 into 10 power minus 20 joule second. This is for the energy. So, from this energy, so kinetic energy, so we are going to find the velocity. So, as we know that a kinetic energy half mp square. So, E is equals to half mp square. So, from that V square is equals to 2E by n, where V is equals to 2E by n whole power half. So, the substituting the values, E is the 5.468 into 10 power minus 20, which we got here. And then mass of the electron is 9.1 into 10 power minus 31. So, whole power 1 by 2. So, while calculating this, we'll get a velocity of electron V is equals to 0.346 into 10 power 6 meters per second. Next problem. Determine the de Broglie wavelength associated with a proton moving with a velocity of 1 by 10 of velocity of light. Mass of proton is equals to 1.674 into 10 power minus 27. So, the given data is velocity of proton. So, what is the velocity of proton? So, proton moving with a velocity, so which is 1 by 10 of velocity of light. So, velocity of proton Vp is equals to 1 by 10 of velocity of light. So, 1 by 10 of velocity of light, that is C. So, the velocity of light is 3 into 10 power 8 meters per seconds. So, this we can write as 3 into 10 power 7 meters per second. Meters per second, that is. So, 3 into velocity of proton is equals to 3 into 10 power 7 meters per second. And also mass of the proton, mp is equals to 1.674 into 10 power minus 27 kilogram. So, we need to calculate the de Broglie wavelength. De Broglie wavelength which is associated with proton. So de Broglie wavelength lambda p. P is for proton. So lambda p is equals to h by mp p. So the formula is lambda is equals to h by mp. So h is Planck's constant, m is the mass of the proton here in this case, and v is the velocity of the proton. So that substituting 6.625 into 10 power minus 34 divided by 1.674 into 10 power minus 27 into 3 into 10 power minus 27. So proton mass is 1.674 into 10 power minus 27, and the velocity of the proton is 3 into 10 power 7 meters per second. So calculating, we will get 1.319 into 10 power minus 14 meters. This is the wavelength of proton moving with velocity 1 by 10 of velocity of light. Estimate the wavelength of an electron rose to a potential 15 kilovolts. So electron potential V is equals to 15 kilovolts. So kilo means 1000. So 15,000 volts. And wavelength of electron we have to find lambda. So here the formula, the particle which is accelerated with some potential have the wavelength lambda is equals to 12.26 divided by root v angstrom. So this is the formula for the particle which is accelerated with some potential difference. So it is equals to 12.26 divided by 15,000 volts. So lambda is equals to 0.1 angstroms. 1 angstroms. Next one, obtain de Broglie wavelength of neutron. Given kinetic energy of the neutron is 0.025 electron volts, mass of neutron is equals to 1.674 into 10 power minus 27 kilogram. So the given data is kinetic energy. So kinetic energy is 0.025 electron volts. So kinetic energy is 0.025 electron volts, and the mass of the neutron is 1.674 into 10 power minus 27 kilogram. So we have to find neutron's wavelength. So the formula is lambda is equals to h by root 2m a. So this is the energy here. So this one is Planck's constant. M is the mass of the neutron here. So it is equals to, so h is Planck's constant. So which have the value 6.625 into 10 power minus 34 joule second. M is the mass of the neutron. So the mass of the neutron has given 1.674 into 10 power minus 27 kilogram. And E is the kinetic energy. So this kinetic energy is given 0.025 electron volts. So when electron volts is converted into volts, then 0.025. So 1 electron volt is 1.6 into 10 power minus 19 joule. So converting into joule, 0.025 electron volts is equals to 0.025 into 1.6 into 10 power minus 19 joule. So that is 1 electron volt is equals to 1.6 into 10 power minus 19 joule. So H is equals to 6.625 into 10 power minus 34 divided by root of 2 into 1.674 into 10 power minus 27 into 0.025 to 1.6 into 10 power minus 19 joule. So calculating this, we'll get 2.8625 into 10 power minus 10 meters. So this is the wavelength of neutron. Wavelength of neutron. So mv square to mv. So this it would come here. So next problem, calculate the velocity and kinetic energy of an electron of wavelength 1.66 into 10 power minus 10 meters. So here we have to calculate velocity and then kinetic energy of wavelength of the electron 1.66 into 10 power minus 10 meters. So lambda is given 1.66 into 10 power minus 10 meters. So this is for the electron. So we need to find the kinetic energy and then velocity. So formula is lambda by mv. So lambda is equals to h by mv. So from this we are going to calculate the velocity because we know m, h, lambda. So we are going to calculate the velocity. P is equals to h by m lambda. So h is equals to 6.625 into 10 power minus 34 joule second. M is mass of the electron. So 9.1 into 10 power minus 31 kilograms. And lambda is given 1.66 into 10 power minus 10 meters. So substituting 6.625 into 10 power minus 34 divided by 9.1 into 10 power minus 31 into 1.66 into 10 power minus 2. So the value becomes 0.438 into 10 power 6 meters per second. So this is the velocity of the electron. So now we are going to find the kinetic energy. So kinetic energy is equals to half mv square. So half into 9.1 into 10 power minus 31 into v is 0.438 into 10 power 6 square. So that 1.99 into 10 power minus 19 joule. This is the kinetic energy of the electron. Next one, an electron is confined in a three-dimensional box of size 0.1 nanometer. Find the ground state energy and first three excited state energies in electron volts. So electron is confined in a three-dimensional box of side 0.1. So the length is L is equals to 0.1 nanometer. So that is equals to 0.1 into 10 power minus 9 meters. Find ground state energy. Ground state energy and then first three excited state energies in electron volts. So for three-dimensional, n is equals to 1. So for three-dimensional box, n is equals to 1. We need to find the energies. We need to find the ground state energy and first three excited states. So in the three-dimensional box, so in x, y, z axis, the n. So nx is equals to 1, ny is equals to 1, nz is equals to 1. So the energies, the formula for the eigenenergies, E is equals to n square h square by 8m L square. So here in this case it is belongs to 3-dimensional. So E is equals to nx square plus ny square plus nz square into h square by. So this is for 1-dimensional. This is for 3-dimensional. So 8m L square. So in this case the ground state energy. So as here in this eigenenergies, there is no zero. There is no zero level of energy. That is when n is equals to 0, the eigenenergy becomes 0, because the zero energy won't be exist in the infinite potential box. So that there is no value of n is equals to 1. So n is equals to 0. So we have to take n is equals to 1. So then we will get a ground state energy. So here for 1-dimensional, E is equals to n square h square by 8ml square. So where n is equals to 1, 2, 3 and so on. See here no 0 is mentioned. If we put 0, E is equals to 0 square h square by 8ml square. So the eigenenergy becomes 0. So there is no there is no zeroth level of the particle won't be with a 0 energy in the potential box. So that's why 0 does not exist. N is equals to 0 does not exist in the potential box. Okay, so that n is equals to 1, 2, 3 and so on. If n is equals to 1, it belongs to ground state. If n is equals to 2, it is the n is equals to 1 ground state. So then the first excited state, second excited state, third excited state. So that if n is equals to 1, it is ground state. If n is equals to 2, we will get first excited state. N is equals to 3, we will get second excited state. N is equals to 4, we get third excited state. So that is here, this is the ground energy level. Then like this, E1, E2, E3, E4, E5. So this is n is equals to 0. Here n is equals to 1. So this is the first excited state. So a first excited state, n is equals to 1. So this is ground state. So when n is equals to 0, we'll get energy of the ground state. Then when n is equals to 1, if we put, we'll get first excited state. This is the first excited state. First excited state. This is second excited state. So if the electron in the ground state, it gains some energy, it excites to higher energy level. So that it is the first excited state. When n is equals to, so n is equals to 1, we'll get ground state energy. N is equals to 2, we'll get first excited state. N is equals to 3, we'll get second excited state. So this is second excited state. So even when n is equals to 1, we'll get ground state energy. When n is equals to 2, we'll get first excited state energy. When n is equals to 3, we'll get second excited state. So first, second, third, fourth. These are the excited states. This one n is equals to 1. Here we'll get ground state energy. So that n is equals to 0 does not exist. Because particle with zero energy does not exist in the potential box. So E1. So that is n is equals to 1. We'll get ground state energy. N is equals to 1. We'll get ground state energy E1. E1 is equals to 1 square plus 6.625 into 10 power minus 34 whole square divided by 8. M is 9.1 into 10 power minus 31 into L is 0.1 nanometer. So 0.1 into 10 power minus 9 meters whole square. So this one we get 18.06 into 10 power minus 18 joule. Minus 18 joule. So this is E1. E1 means ground state energy. Ground state energy. When we get a ground state energy, n is equals to 1. So first excited state means E2. So E2 will get when n is equals to E2 is equals to, that is 1, will get 1 square plus 1 square plus 2 square. So next third excited state, that is the states will be in this way, not in this way. That is if we take three-dimensional, the particle will excites in this way. So this is first excited state. If we take the box, okay, the particle will be excited in this way, that is in z direction. So z, y and x, or y or x. So that n is equals to 1, nx is equals to 1. So nx is equals to 1, ny is equals to 1, nz is equals to 1. So that all will be x, y, z axis. N is equals to 1 when it is in the ground state. If the particle is excited, so that in z direction it is moving, so that nz becomes 2 in the first excited state. So for the second excited state, nz becomes 3. This is A2, here A1, A3, A4. So n is equals to 1, that is in 3-dimensional. Nx is equals to 1, ny is equals to 1, nz is equals to 1. For this, the energy E1, for the ground state energy E1, for E1, which is for ground state. So nx is equals to 1, ny is equals to 1, nz is equals to 1. If E2 is first excited state. So first excited state will get when n is equals to 2. N is equals to 2 in the sense, so if the particle is in the potential box, if the particle will excite, it will move in the z direction, not in x and y direction. So that nx will be 1, ny is equals to 1, nz is equals to 2. Because it is the first excited state, so that nz, it moves in the z direction, so that nz becomes 2 for the first excited state. Like that, E3, that is second excited state. So second excited state will get n is equals to 3. When n is equals to 3. So in this case, nx is equals to 1, and y is equals to 1, and z, so it is going to other exciter level in z direction, so that nz becomes 3. So for the third excited state, E4 is the third excited state. So third excited state occurs at when n is equals to 4. So n is equals to 4 in the sense here this one. Third excited state, n is equals to 4. So nx is equals to 1, and y is equals to 1, and z is equals to 4. So that's why nz only changing the number according to the excited state, not for nx and ny. So when in the three-dimensional case. So that the first excited state E2 is equals to 1 square plus 1 square plus 2 square. So substituting the Planck's constant and mass of the electron and then length of the box. So we'll get E2 is equals to 22.6085 electron volts, because here we get joules. So we substitute the value of Planck's constant in joules. So the value we get here in joules. So that is 6.1736 into 10 power minus 19 joules. So but here they mentioned in electron volts. So 1.6 into 10 power minus 19. So 1 electron volt is equals to 1.6 into 10 power minus 19 joules. So that multiplying this with dividing with 1.6 into 10 power minus 19, we will get 22.6085 electron volts. For the second excited state, E3 is equals to, here nx is equals to 1, ny is equals to 1, nz is equals to 3. So substituting the values and calculating, we will get 66.318 into 10 power minus 19 joule. 66.318 into 10 power minus 19 joule. So 1 electron volt is equals to 1.6 into 10 power minus 19 joules. So that we have to converting into electron volts, we'll get the value 41.44 electron volts. So here also for the third excited state, nz becomes 4. So substituting and calculating, we'll get 67.825 electron volts. Calculate the energies that can be possessed by a particle of mass 8.5 into 10 power minus 31 kilogram, which is placed in an infinite potential box of width 10 power minus 9. So the given data is mass of the particle m is equals to 8.50 into 10 power minus 31 kilogram. Length is width, that is L is equals to 10 power minus 9 meters. And then calculate the energies that can be possessed by a particle having mass which is placed in an infinite potential box of width 10 power minus 9. So we have to calculate the energies, and it is not mentioned, and there it is not mentioned for which state it is. Okay, so that we are taking energies in the sense we are taking two energies, two levels. So n is equals to 1 and n is equals to 2. So when n is equals to 1, we'll get a ground state energy. When n is equals to 2, we'll get first excited state energy. So for one dimensional, the eigen energy E is equals to n square h square by 8m L square. So that it is one dimensional, so that n square is 1. So for the first case, 1 square, h square is 6.625 into 10 power minus 34 joules square by 8 into. So we know that mass of the particle is 8.5 into 10 power minus 31 kilogram into L is 10 power minus 9 meters whole square. So we'll get 0.6454 into 10 power minus 19 joule. So this is for ground state, and for first excited state, we'll substitute the n value 2. 2 square into 6.625 into 10 power minus 34 whole square divided by 8 into 8.5 into 10 power minus 31 into 10 power minus 9 whole square is equals to 2.528 into 10 power minus 90 joule. So these are the energies of the particle. Find the lowest energy of an electron confined in a square box of side 0.1 nanometer. So the data given in length of the box. So L is equals to 0.1 nanometer. So 0.1 into 10 power minus 9 meters. So here it is square box, confined in a square box. So square box in the sense it is a 3-dimensional. So in 3-dimensional, nx is equals to 1, ny is equals to 1, nz is equals to 1. Why I am taking this nx is equals to 1, ny is equals to 1, nz is equals to 1? Because we are going to find the lowest energy. So we are going to find the lowest energy. So lowest energy occurs when n is equals to 1. Because n is equals to 0 does not exist. So that the lowest energy will occur at n is equals to 1. So for 3-dimensional, nx is equals to 1, ny is equals to 1, nz is equals to 1. That is ground state energy. So for the formula for eigenenergy for 3-dimensional, nx square plus ny square plus nz square h square divided by 8m L square. So it is equals to 1 square plus 1 square plus 1 square. So into 6.625 into 10 power minus 34 joule second square into 8 into 9.1 into 10 power minus 31. Because here it has been given electron. So electron mass is 9.1 into 10 power minus 31. We know that. So the dimension, length, width of the side box is 0.1 into 10 power minus 9 whole square. So E1, that is lowest energy. E1 is equals to, lowest energy means ground state energy. E1 is equals to 18.06 into 10 power minus 18 joule. This is the lowest energy of the electron which is confined in the square box of 0.1 nanometer. Next one, electrons are accelerated by 344 volts and are reflected from a crystal. The first reflection maximum occurs when the glancing angle is 60 degrees. Determine the spacing of the crystal. So the given data, potential energy V is equals to potential difference, V is equals to 344 volts. And the order of reflection is n is equals to 1, glancing angle is 60 degrees, and spacing of the crystal we have to find. So from the Brock's law, n lambda is equals to 2d sin theta, we can calculate the interplanar spacing distance. So d is equals to n lambda by 2 sine theta. But before that, we have to know the lambda value. To find the d, we have to calculate the lambda. The wavelength of accelerated electron lambda is equals to 12.26 divided by root of 344. So that is equals to 12.26 divided by 18.5472. So that is equals to 0.6610 meters. So this is for the electron which is accelerated. So usually lambda is equals to h by root of 2m eV. So in this case, when substituting the values of mass, charge and Planck's constant, the lambda will comes 12.26 into root v. So that the accelerated electron wavelength lambda is equals to 12.26 divided by root v. So v is 344. So that 12.26 divided by root of 344 is equals to 0.6610 meters. Then substituting this lambda in the interplanar spacing d. So d is equals to n lambda by 2 sine 60 degrees. So it is equals to 0.382 meters. So the distance, the spacing of the crystal d is equals to 0.382 meters. Next, an electron is bound in one dimension infinite well of width 1 into 10 power minus 10 meters. Find the energy values in the ground state and first two excited state. So the given data is width 1 into 10 power minus 10 meters. 1 into 10 power minus 10 meters. And we have to calculate the ground state energy and first two excited state energies. So when n is equals to 1, we'll get ground state energy. When n is equals to 2, n is equals to 3, we'll get E2 and E3. So E2 is first excited state, energy of first excited state. E3 is the second excited state energy. So we have to find the energy values in the ground state and first two excited states. So three energy levels we are going to find. So for one dimensional, En is equals to n square plus n square by 8m L square. So E1 is equals to n is equals to 1 square h square. H square is 6.625 into 10 power minus 34 whole square divided by 8 into 9.1 into 10 power minus 31, where the width of the box is 1 into 10 power minus 10 meters. So 1 into 10 power minus 10 square. So calculating this, we'll get 0.603 into 10 power minus 70 joule. So this is the ground state energy. So this ground state energy will get by substituting n is equals to 1. So the first two excited state, n is equals to 2 and n is equals to 3. So for first excited state, the formula we can get 4E1. So let's substituting 4 into E1. The E1 value is 4 into 0.603 into 10 power minus 17. So we'll get 2.412 into 10 power minus 17 joule. Where the second excited state E3 is equals to 9E1 So 9 into E1 is 0.603 into 10 power minus 17 joule. So we'll get 5.428 into 10 power minus 17 joules. So these are the ground state energy and then first two excited states energies. So the references are Engineering Physics by Tyagarajan, McGraw-Hill Education Private Limited, New Delhi. A textbook of Engineering Physics by M.N. Avadhanulu, P.G. Kshirshagar, S. Chand and Company, New Delhi. Engineering Physics by Dr. M. Armugam, Anuradha Publications, Chennai, 6,70,000. Engineering Physics by P.K. Palanisamy, 4th edition, SciTech Publication, India Private Limited, Chennai, 6,70,000. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.